The Ice Age wasn't just one long freeze. It was a series of glacial advances and retreats that turned Earth into a testing ground for survival, a place where only the biggest, smartest, and most brutal predators made it through. While glaciers carved valleys and mammoths stomped across frozen grasslands, something else was happening in the shadows and the snow. Evolution was building killing machines. Some had teeth longer than your forearm. Others hunted in packs with strategies that would make modern wolves look amateur. A few were so perfectly adapted to murder that when the ice melted and the world warmed up, they couldn't exist anymore. In this documentary, we're looking at 17 prehistoric predators that ruled the Pleistocene, the ones that turned the Ice Age into a horror show with fur and fangs. Smilodon, the saber-toothed cat that wasn't built like any cat today. Picture a cat. Now make it the size of a modern lion, give it shoulders like a bodybuilder, and stick 2 curved daggers in its mouth that hang down past its chin. That's Smilodon, the animal everyone calls a saber-toothed tiger, even though it's not a tiger and didn't hunt like one either. Those famous canines, sometimes 8 inches long, weren't just for show. They were precision killing tools, but using them required a completely different attack strategy than what big cats use today. Smilodon fossils show up across North and South America, from California to Argentina. The most famous concentration is the La Brea tar pits in Los Angeles, where thousands of individuals got stuck over tens of thousands of years. The bones are so common there that researchers have been able to study everything from bite force to injury patterns to how often these cats broke their teeth. And they broke them a lot, which tells you something about how hard they were pushing their weapons. The skull design is the giveaway that this wasn't a normal cat. Modern big cats, lions, tigers, leopards, kill with a suffocating bite to the throat or a crushing bite to the skull. Their jaws are built for clamping power. Smilodon's jaw, though, could open to an angle of about 120 degrees, twice what a lion manages. That extreme gape wasn't for biting harder. It was for getting those sabers out of the way so they could actually be used like knives instead of clubs. Here's the problem with having teeth that long. They're fragile. If Smilodon tried to wrestle a struggling, kicking prey animal while biting, those canines would snap. Fossil evidence shows exactly that happening. Broken saber tips are common. So how did it hunt without breaking its main weapons every time? The answer seems to be in the body. Smilodon had massively muscled shoulders and forearms, way more robust than a modern lion. It was built to grapple, pin and hold prey down using sheer strength, the way a wrestler controls an opponent. Once the prey was immobilized, Smilodon would deliver a precise, deep bite to the throat or belly, slicing through soft tissue and major blood vessels with those sabers. It wasn't a crushing bite, it was a stab. The victim would bleed out fast. The thick neck muscles and powerful shoulders meant Smilodon could drive the bite home with force, even if the jaw itself wasn't designed for pressure. In a way, it was less like a cat and more like a guided missile with knives. But that strategy came with costs. Smilodon couldn't just chase down fast prey across open ground like a cheetah. It was too heavy, too muscular, built for short bursts, and power rather than endurance. It likely ambushed from cover or targeted slower, larger animals that couldn't easily escape. The environment had to provide the right mix: enough big herbivores, enough cover to hide in, and enough food to support an animal that probably needed a lot of calories to maintain all that muscle. There's also the question of pack hunting. Some researchers think Smilodon might have lived and hunted in groups, like lions do. Evidence for this comes from the healed injuries on fossils, broken bones that mended, suggesting the animal survived long enough to recover, maybe because group members brought it food. That's speculative, but it's hard to imagine a solitary, injured Smilodon with a busted leg hunting successfully on its own. If they did work in groups, that would make them even more terrifying, coordinated, powerful, armed with knives. By the end of the Pleistocene, smilodon was gone. The exact cause is debated: climate change, loss of prey, competition with humans, or some mix. What's clear is that their hyper-specialized design, so perfect for the Ice Age, became a liability when the world changed. You can't just switch from stabbing giant ground sloths to chasing deer. The sabers, the bulk, the whole strategy, it locked them into a niche. When that niche collapsed, so did they. Homotherium, the scimitar cat that hunted on glaciers. If Smilodon was the heavyweight wrestler, Homotherium was the distance runner with knives. It's often called the scimitar cat because its saber teeth were shorter, flatter, and more curved than Smilodon's daggers. At first glance, you might think it's just a lesser version of the more famous saber-tooth. But look closer at the skeleton, and you see an animal built for a completely different kind of hunt, one that took it into environments most big cats would never touch. Homotherium was leaner than Smilodon, with longer legs and a sloping back that looks almost hyena-like. The front limbs were longer than the back ones, giving it an odd, forward-tilted posture. That build suggests it was more cursorial, built for covering ground, not just explosive power. It could chase prey over longer distances, something Smilodon probably couldn't do. The teeth, while still impressive, were designed to slice, rather than puncture, deeply. Think of them less as daggers and more as serrated carving knives. Fossils of Homotherium have turned up in some strange places: North America, Europe, Asia, even Africa. But one of the wildest finds came from the North Sea, where a nearly complete skeleton was pulled from sediments that were once dry land during the Ice Age. The area, called Doggerland, was a cold, flat expanse connecting Britain to mainland Europe. The fact that Homotherium lived there tells you it was comfortable in harsh, frigid environments that other big cats avoided. The scimitar cat's hunting strategy probably focused on young or medium-sized prey rather than the giant smilodon might target. Its teeth could shear through hide and muscle efficiently, and the longer legs meant it could pursue animals across open tundra or patchy forests. Some researchers think Homotherium might have specialized in hunting juvenile mammoths or young bison, animals big enough to be worth the effort, but not so massive that they required the grappling power Smilodon had. What really sets Homotherium apart, though, is where it hunted. There's evidence that it lived and operated near glaciers and ice fields, places where the cold was constant and the prey had to be tough to survive. A find in the Yukon turned up a Homotherium den with the remains of juvenile mammoths inside. That's not opportunistic scavenging. That's active predation on one of the most dangerous prey types imaginable, even when they're young. The slicing teeth make sense in that context. A quick, deep slash across the legs or belly of a mammoth calf could cripple it, and then the cat could back off and wait for blood loss and shock to do the rest. It's a strategy that minimizes risk. No prolonged wrestling match with an animal that could crush you. Just cut and retreat. The cold environment would work in the predator's favor too, as blood loss in freezing temperatures leads to faster death. Homotherium also had unusual nasal openings and sinus structures, which some scientists think helped it breathe more efficiently in cold, thin air. If that's true, it's another piece of evidence that this cat was specifically adapted to life on the edges of the ice, hunting in conditions that would stress or kill other predators. It wasn't just surviving in the cold, it was thriving there, exploiting a niche that most carnivores couldn't touch. The extinction of Homotherium is almost as mysterious as the animal itself. It vanished from most of its range before the very end of the Ice Age, earlier than Smilodon. In some places, it might have lasted longer. There are controversial claims of late surviving populations in South America, and possible sightings recorded in indigenous stories, though nothing confirmed. What killed it off is unclear. Maybe it was too dependent on specific prey. Maybe climate shifts disrupted the cold grasslands it preferred. Or maybe it just ran out of room when other predators moved in. Panthera spelaea, the cave lion that ruled Europe. Take a modern lion, scale it up by about 10%, bulk up the legs, and drop it into Ice Age Europe and Asia. That's Panthera spelaea, the cave lion. Despite the name, it didn't live in caves full time. The cave part comes from where we find the bones, sheltered spots where remains were preserved instead of scattered across open ground. But make no mistake, this animal spent most of its life outside, roaming cold grasslands and hunting across a landscape that looked nothing like the African savanna we associate with lions today. Cave lion fossils show up from Spain to Siberia and even into Alaska. The range is staggering. These weren't isolated pockets of populations. This was a predator that dominated the northern Pleistocene world, thriving in environments that modern lions wouldn't last a week in. The body was heavily built, with thick bones and powerful limbs. Males could weigh over 700 pounds, significantly larger than today's African lions. One of the strangest things about Panthera spelaea is what we know from art. Ice Age humans painted and carved images of these lions on cave walls, and those images show details that bones alone can't tell us. The depictions suggest cave lions had minimal or no manes, unlike modern male lions. That makes sense in a cold climate. A thick mane would collect ice and snow, adding weight and making movement harder. Instead, cave lions may have had short, dense fur across their whole bodies, insulating without the bulk. The prey base for cave lions was completely different from what modern lions eat. Instead of zebras and wildebeest, they were hunting reindeer, horses, bison, and young mammoths. These are tougher, more heavily built animals adapted to cold climates, with thicker hides and more muscle mass. Killing them would require different tactics, more power, more precision, and probably more cooperation. The fossil record shows cave lions with healed injuries, consistent with hunting large, dangerous prey that fought back. There's ongoing debate about whether cave lions lived in prides like modern African lions, or were more solitary like tigers. The evidence leans slightly towards social behaviour. Multiple individuals have been found together, and the structure of the environment, wide open tundra and steppe, favours group hunting, just like it does on the African savanna. A lone hunter in that kind of landscape has a harder time getting close to prey without being spotted. A coordinated group can drive, flank, and overwhelm. One of the most detailed cave lion finds came from Siberia, where permafrost preserved not just bones, but soft tissue, fur, and even stomach contents. The animal was a cub, but the preservation was so good that scientists could see muscle structure, examine the teeth in detail, and analyze fur color and texture. It confirmed that cave lions had thick, pale fur, likely an adaptation for camouflage in snowy environments. It also showed that their build was more robust than modern lions, with shorter, stockier limbs built for power rather than speed. The extinction of Panthera spelaea happened near the end of the Pleistocene. Around the same time, many other megafauna disappeared. Climate change is the easy answer. As the ice retreated and forests expanded, the open grasslands cave lions depended on shrank. Prey populations shifted, and the hunting grounds changed. But humans were spreading into cave lion territory during this time too, competing for the same prey and possibly hunting the lions themselves. Spear points have been found near cave lion remains, though whether those were defensive kills or deliberate hunts is unclear. There's also the question of genetics. Studies comparing cave lion DNA to modern lions show they were closely related but distinct enough to be considered a separate subspecies or even species. Some researchers think cave lions could have interbred with the ancestors of modern lions at their range boundaries, meaning a tiny fraction of their genes might still exist in living populations. If that's true, the cave lion isn't entirely gone. It's just diluted, dissolved into the gene pool of its African relatives. Canis dirus, the dire wolf that wasn't a wolf at all. Everyone knows the dire wolf from fantasy novels and TV shows, but the real animal is stranger and more tragic than fiction ever made it. For over a century, scientists thought Canis dirus was just a bigger, beefier version of the grey wolf, Canis lupus. Same family, same behaviour, just scaled up for tackling Ice Age megafauna. Then, in the last few years, genetic studies dropped a bomb. Dire wolves weren't wolves at all. They were so distantly related to modern wolves that they couldn't even interbreed. They were something else, something older, something that had been evolving separately for millions of years. Dire wolves were built like tanks. Compared to grey wolves, they had shorter, stockier legs, a more massive skull, and bone-crushing jaws. The average dire wolf weighed about 150 pounds, with some individuals pushing closer to 200. That's significantly larger than most modern wolves. But the difference wasn't just size, the proportions were off. A grey wolf is built for endurance running, chasing prey over long distances until it collapses. A dire wolf was built more like a hyena, with the power to hold, crush and tear rather than chase. The teeth tell the story. Dire wolves had larger, more robust carnassials, the blade-like teeth used for slicing meat, and their premolars were thicker and more suited to cracking bone. Wear patterns on fossil teeth show they were crunching through. Goo regularly, something grey wolves avoid because it risks breaking teeth. But dire wolves had more to spare, or maybe their lifestyle demanded it. They were feeding on carcasses, scavenging as much as hunting, and getting every last calorie out of a kill. Fossil sites back that up. The La Brea tar pits in California contain more dire wolf bones than any other mammal, over 4,000 individuals. That's not random. The tar pits were natural traps where herbivores would get stuck, drawing in carnivores and scavengers that also got stuck. Dire wolves, with their scavenging habits and competitive pack behaviour, probably showed up in large numbers to exploit easy meals. It's the same pattern you see with modern hyenas at lion kills. They weren't the top predators, but they were everywhere, capitalising on the work of others or their own bad luck. But the pack behaviour raises questions. Did dire wolves hunt cooperatively like grey wolves, or were they more opportunistic, forming loose groups around carcasses like hyenas? The fossil evidence leans toward packs. Multiple individuals of different ages and sizes are found together, suggesting long-term social groups rather than temporary feeding aggregations. That implies coordination, communication, and maybe even care for injured pack members. Some fossils show healed injuries that would have been debilitating, meaning the animal survived with help from the group. The big shocker came from ancient DNA studies. Researchers managed to extract and sequence genetic material from dire wolf bones and compared it to modern canids. The results showed that dire wolves split from the lineage leading to wolves, coyotes and dogs over 5 million years ago. That's before the Ice Age even started. They weren't a sister species to wolves. They were a separate branch altogether, one that had been running its own evolutionary experiment in parallel. That separation explains some of the weirdness. Dire wolves never left the Americas, while grey wolves ranged across the entire northern hemisphere. Despite living in the same environments, hunting similar prey and facing the same pressures, they never interbred or merged. They were genetically isolated, locked into their own trajectory. When the Ice Age ended and the big herbivores started disappearing, dire wolves couldn't adapt. They couldn't shift prey, couldn't follow the herds into new ranges, couldn't interbreed with more flexible canids. They were stuck. The last dire wolves disappeared around 10,000 years ago, right at the end of the Pleistocene. Their extinction coincides with the collapse of Ice Age megafauna across North and South America. With mammoths, ground sloths and giant bison gone, the scavenging opportunities dried up. Grey wolves, coyotes and other more adaptable canids moved into the niche, and dire wolves couldn't compete. They were specialists in a world that suddenly didn't need them anymore. Arctodus simus, the short-faced bear that could outrun you. Forget grizzlies, forget polar bears. If you had to face a bear in the Ice Age, the one you'd least want to meet is Arctodus simus, the giant short-faced bear. This animal was built wrong. It stood up to 12 feet tall on its hind legs and weighed over a ton, making it one of the largest terrestrial carnivores in North America. But the really disturbing part isn't the size, it's the speed. While modern bears are fast in short bursts, Arctodus had long stilted legs that suggest it could run down prey over distance, something no bear alive today can do. The skull gives this bear its name. Compared to a brown bear or black bear, the short-faced bear's snout was abbreviated, broad and filled with massive teeth. The jaw structure and muscle attachments indicate ridiculous bite force, capable of crushing bone and tearing through thick hide. But the teeth themselves weren't just for meat. Wear patterns and isotope studies suggest Arctodus was a hypercarnivore during some periods, eating almost nothing but meat, unlike the omnivorous diet of modern bears. That carnivorous specialization is weird for a bear. Most bears, even big ones like grizzlies, eat a mixed diet: berries, roots, fish, scavenged meat, whatever's available. Arctodus seemed to focus more heavily on meat, and the body plan backs that up. The limbs are long and gracile compared to a grizzly, not as bulky or heavily muscled for digging or climbing. This wasn't a bear that spent a lot of time ripping apart logs for insects or excavating roots. It was built for movement, for covering ground, for hunting or scavenging across wide territories. The long legs have triggered a lot of debate. Some researchers think Arctodus was primarily a scavenger, using its size and speed to chase smaller predators like saber-toothed cats off their kills. The bear shows up, the cats scatter, and Arctodus eats. It's a viable strategy and the anatomy fits. But others argue that an animal this big, this fast, and this heavily armed could absolutely hunt on its own. Why waste energy chasing others off kills when you could just run down a bison or deer yourself? Fossil sites show Arctodus living alongside other major predators: smilodon, dire wolves, American lions. That's a crowded lineup. In that kind of competitive environment, being a pure scavenger seems risky. You'd be fighting for scraps constantly. More likely, Arctodus was flexible. It hunted when it could, scavenged when opportunities arose, and used its size to dominate any feeding situation it entered. Nothing would challenge a full-grown short-faced bear, except maybe another short-faced bear. The range of Arctodus stretched from Alaska to Mexico, covering a huge variety of habitats: tundra, grasslands, open woodlands. That adaptability suggests it wasn't locked into one prey type or one hunting style. In the north, it might have targeted caribou and muskox. In the south, bison and horses. Wherever it lived, it was probably the apex predator, the thing at the top of the food chain that nothing else wanted to mess with. There's also the question of hibernation. Modern bears hibernate to survive winter when food is scarce. Did Arctodus do the same? The body plan, long-legged, lean, built for movement, doesn't scream hibernator. It looks more like an animal that stays active year-round, following prey or carcasses across the landscape. But the fossil evidence isn't clear enough to settle it. Maybe younger bears stayed active while older, heavier individuals denned up. Maybe they only hibernated in the harshest parts of their range. Or maybe they didn't hibernate at all, relying on their hunting skills and size to keep them fed through winter. Arctodus disappeared around 11,000 years ago, near the end of the Pleistocene megafaunal extinctions. The loss of large herbivores would have hit them hard, especially if they were as meat-focused as the evidence suggests. With mammoths, horses, and giant bison declining or gone, the food base collapsed. Smaller, more omnivorous bears like brown bears and black bears could switch to eating more plants, fish, and insects. Arctodus, locked into its hypercarnivorous niche, couldn't pivot fast enough. When the meat disappeared, so did the bear. Zenosmilus hodgsoni, the cookie cutter killer from Florida. Most saber-toothed cats get lumped together in people's minds, but Zenosmilus hodgsoni was playing a completely different game. Found in Florida, this cat had sabers, sure, but they were short, thick and serrated like a steak knife. It wasn't built for deep stabbing like smilodon or slicing like homotherium. It was built for cutting out chunks of flesh in fast, brutal bites, the way a shark attacks. The name even means strange knife, and once you look at the anatomy, you see why that's perfect. Zenosmilus was discovered in a limestone cave system in northern Florida, in deposits dated to around 1 million years ago. The fossils aren't complete, but what we have shows an animal about the size of a leopard, heavily muscled, with unusually robust front limbs and a shortened tail. The body was built for power over speed, more like a wolverine than a typical cat. It wasn't chasing prey across open ground. It was ambushing, grappling, and delivering fast, devastating bites. The teeth are the key. Unlike smilodon's smooth, blade-like sabers, Zenosmilus had serrations along both edges of the canines. That's rare in mammals, much more common in reptiles and fish. Serrated teeth are better at cutting through tough material. Think of the difference between a smooth knife and a bread knife. Zenosmilus could bite and tear at the same time, ripping out muscle and blood vessels in a single motion. It didn't need to hold on for long. Get in, cut deep, get out. The jaw structure suggests it wasn't biting down as hard as smilodon. The muscle attachments and skull shape show more emphasis on speed of the bite rather than pressure. That matches with the serrated teeth. You don't need as much force if your weapon is already designed to cut efficiently. A fast, shallow bite with those sabers could open an artery or slice through a muscle group, crippling the prey immediately. The short tail is odd. Most cats use their tails for balance, especially during quick turns or climbing. Zenosmilus had a tail more like a bobcat or lynx, stubby and abbreviated. That suggests it wasn't doing a lot of running, leaping or climbing. It was probably a terrestrial ambush predator, hiding in thick cover and launching short, explosive attacks. The prey wouldn't see it coming, wouldn't have time to escape. By the time the victim realized it was under attack, the damage was already done. The environment Zenosmilus lived in was very different from the frozen tundra most Ice Age predators inhabited. Florida 1 million years ago was warm, humid, and full of dense vegetation. It wasn't open grassland where you could chase down prey over distance. It was thick forest and swamp, where visibility was low and ambush tactics ruled. In that setting, Zenosmilus's strategy makes perfect sense. Hide, wait, explode forward, bite, retreat. The prey bleeds out while the predator stays safe. The prey base would have been different too. Instead of mammoths and bison, Zenosmilus was probably targeting deer, peccaries, and smaller herbivores that lived in forested areas. These animals were fast, alert, and hard to catch in open country, but in dense cover, the advantage flipped. A predator that could burst from concealment and deliver a single crippling bite didn't need to be faster. It just needed to be patient and precise. Zenosmilus went extinct long before the end of the Ice Age, disappearing from the fossil record around 500,000 years ago. The reasons aren't clear. Climate shifts might have changed the vegetation, reducing cover and making ambush hunting harder. New predators might have moved in, outcompeting it for prey. Or maybe it was too specialized, locked into a strategy that only worked in specific conditions. When those conditions changed, the cookie-cutter killer had no backup plan. Panthera atrox, the American lion boucan that dwarfed African pride. If the cave lion was the king of Ice Age Europe, Panthera atrox was its even bigger cousin running the show in the Americas. The American lion was one of the largest cats that ever lived, rivaling or exceeding even the biggest cave lions in size. Estimates put large males at over 800 pounds, possibly reaching 1,000 in extreme cases. To put that in perspective, a modern male African lion averages around 400 pounds. Panthera atrox was more than double that, a scaled-up killing machine built for a continent packed with massive prey. Fossils of Panthera atrox show up from Alaska to Peru, covering nearly the entire Western Hemisphere. That range tells you this cat was adaptable, capable of handling everything from frozen tundra to temperate forests to open grasslands. It wasn't locked into one environment or one prey type. Wherever large herbivores existed, the American lion was there, hunting them down. The skull of Panthera atrox is enormous, with massive jaw muscles and teeth built for grabbing and holding rather than slicing. This wasn't a saber-tooth. It killed more like a modern lion, with a suffocating throat bite or a crushing bite to the skull or spine. But the sheer size meant it could target much larger prey than an African lion would dare attempt. Bison, horses, camels, and even juvenile mammoths and ground sloths were all on the menu. One interesting detail is the limb proportions. American lions had slightly longer legs relative to body size compared to modern lions, which suggests they were better at sustained running. In the open grasslands and tundra of Ice Age North America, prey animals had nowhere to hide. Hunts would involve long chases across flat ground, and a predator that could maintain speed and stamina would have a huge advantage. Panthera atrox seems to have been built for exactly that kind of pursuit. The La Brea tar pits, once again, provide a treasure trove of information. Hundreds of American lion skeletons have been pulled from the tar, showing individuals of all ages and sizes. The bones reveal patterns of injury and disease, including evidence of arthritis, broken bones that healed, and even signs of infection. These cats lived hard lives, constantly pushing their bodies to the limit, in hunts that could leave them injured or scarred. There's ongoing debate about whether Panthera atrox lived in prides like modern African lions or operated more like solitary tigers. The evidence is mixed. Multiple lions have been found together at some sites, suggesting group behaviour, but there's no clear proof of pride structure. Some researchers think American lions might have had a more flexible social system, forming temporary groups when prey was abundant or territory overlapped, but otherwise hunting alone or in pairs. The prey that American lions targeted was often dangerous. A full-grown bison could weigh over a ton, with horns and hooves that could kill a predator in one strike. Horses were fast and alert, difficult to approach in open ground. Ground sloths were massive, armed with claws that could disembowel a lion with a single swipe. Hunting these animals wasn't safe. It required planning, precision, and probably cooperation. A lone lion might take down a deer or peccary, but for the big stuff, working together was the only option. One of the most controversial claims about Panthera atrox involves its relationship to cave lions and modern lions. Early genetic studies suggested they were closely related, possibly even the same species in some classifications. But more recent work has shown greater divergence, with American lions forming their own distinct lineage that split earlier than expected. That would make them less of a big African lion, and more of their own evolutionary experiment that happened to look similar due to convergent evolution. The extinction of Panthera atrox aligns with the end-Pleistocene megafaunal collapse. As large herbivores disappeared, mammoths, horses, camels, giant bison, the lions lost their primary food source. Smaller prey remained, But a predator the size of an American lion needed enormous amounts of meat to survive. Switching to deer and rabbits wasn't viable. The energy return didn't match the energy cost of being that large. When the megafauna crashed, the megapredators follow. Miracononyx, the American cheetah that wasn't actually a cheetah. For years, people called Miracononyx the American cheetah, and for good reason. It looked like a cheetah, ran like a cheetah, and seemed to fill the same ecological role as a cheetah. But here's the twist. It wasn't a cheetah at all. It was a distant relative of the puma, or mountain lion, that had evolved to look and behave like a cheetah through convergent evolution. Same solution, different starting point. And that makes Miracononyx one of the most fascinating examples of evolution copying its own homework. Miracononyx lived in North America during the Pleistocene, ranging from Wyoming to Texas. Two species are recognized: Miracononyx inexpectatus, the earlier and bulkier form, and Miracononyx trumani, the later, more gracile version that looked even more cheetah-like. The second species is the one that really pushes the resemblance. It had long, slender legs, a deep chest for lung capacity, a flexible spine for stride extension, and reduced claws that were only semi-retractable, just like a modern cheetah. The skeleton is built for one thing: speed. The limbs are elongated. The vertebrae are structured to allow the spine to flex and extend during a sprint. And the claws are worn down in a way consistent with running rather than climbing. Miracononyx wasn't stalking through forests or ambushing from cover. It was chasing prey across open ground, relying on explosive acceleration and sustained high-speed running to close the distance. So what was it chasing? The most likely target was the pronghorn antelope, one of the fastest land animals alive today. Modern pronghorns can hit 55 miles per hour and maintain that speed for miles, far faster and more enduring than any predator currently in North America. That speed seems excessive for escaping wolves or coyotes, which max out around 35 to 40 miles per hour. But if you had a predator that could run 60 to 70 miles per hour, like Miracononyx, that pronghorn speed suddenly makes sense. It's not overkill, it's survival. This creates a fascinating evolutionary arms race. Miracononyx got faster to catch pronghorns. Pronghorns got faster to escape Miracononyx. Both species pushed each other toward extreme speed. Each increment of improvement on one side forcing a matching response on the other. When Miracononyx went extinct, the pronghorn was left with speed it no longer needed, a relic of an ancient predator that no longer existed. It's like carrying a bulletproof vest in a world where guns were never invented. The anatomy of Miracononyx supports this high-speed lifestyle, but it also shows the trade-offs. The claws were reduced and blunt, which made them useless for climbing or fighting. If Miracononyx missed a kill or got injured, it couldn't just climb a tree to escape like a leopard, or fight off rivals like a lion. It was built for one thing, and if that one thing didn't work, the cat was in trouble. That kind of specialization is powerful, but fragile. Fossil evidence shows Miracononyx coexisted with other predators: American lions, dire wolves, saber-toothed cats. In that crowded predator guild, the niche of high-speed pursuit specialist would have been valuable. While the lions and saber-tooths targeted large, slower prey, Miracononyx could exploit the fast, medium-sized herbivores that others couldn't catch. As long as pronghorns, horses, and other fleet-footed prey were abundant, the cheetah cat had a place. The extinction of Miracononyx happened around 10,000 years ago, at the end of the Pleistocene. Unlike many other predators, the direct cause isn't obvious. Pronghorns survived. Fast prey was still available. Climate change likely altered the landscape, shifting from open grasslands to more mixed environments with trees and shrub cover. In that kind of terrain, high-speed chases become harder. Visibility drops. Ambush predators have an advantage. A sprinter like Miracinonyx would struggle. There's also the human factor. As people spread into North America, they brought new hunting pressure and competition. They also brought fire, using it to manage landscapes in ways that changed vegetation patterns. If those fires reduced open grassland and increased brush, Miracinonyx's hunting grounds would shrink. Combine that with climate-driven habitat shifts, and you get a predator with nowhere left to run. The American cheetah, built for speed, couldn't outrun the changing world. Panthera gombasoagensis, the European jaguar that hunted in snow. Long before cave lions dominated Ice Age Europe, there was Panthera gombasoagensis, a cat that looked like a jaguar but lived in a world of cold grasslands, forests, and early glacial advances. It's one of the earliest big cats in Europe, appearing in the fossil record around 1.5 million years ago, and vanishing around 500,000 years ago. In that time, it was one of the top predators, filling a role that later species like the cave lion would inherit. Fossils of Panthera gombasoagensis come from sites scattered across Europe and Western Asia, often in association with other early Ice Age fauna, like primitive mammoths, ancient horses, and huge bison. The skull and teeth suggest it was similar in size and build to a modern jaguar or leopard, though some individuals were significantly larger. The jaw was robust, the canines thick and powerful, built for delivering crushing bites rather than precision stabs. That bite style hints at the hunting strategy. Modern jaguars are famous for their ability to bite through the skulls of prey, killing with a direct brain or spine bite. Panthera gombasoagensis seems to have hunted the same way, using brute jaw strength to crack bones and crush vital structures. In a world where prey animals were developing thicker skulls and heavier builds as defense mechanisms, a predator that could just bite through the armor had a serious advantage. The environment this cat lived in was transitional. Europe was shifting between warmer interglacial periods and colder glacial advances. Forests would expand, then retreat. Grasslands would open up, then shrink. Panthera gombasoagensis had to be adaptable, capable of hunting in multiple habitat types and targeting a variety of prey. Fossils show it coexisted with early humans and other hominins, which means competition wasn't just from other predators, it was also from tool-using, intelligent hunters that were getting better at their craft. One of the most interesting aspects is how Panthera gombasoagensis fits into the cat family tree. It's considered one of the ancestors or close relatives of modern jaguars, which raises questions about how jaguars ended up in the Americas while their closest relatives stayed in Eurasia. The current theory is that jaguars, or their direct ancestors, crossed the Bering Land Bridge into North America, then spread south into Central and South America, while their European cousins stayed behind and eventually went extinct. The disappearance of Panthera gombasoagensis coincides with the arrival and spread of larger, more specialized predators like the cave lion. As competition increased and prey populations shifted, the European jaguar couldn't keep up. It wasn't as big as the cave lion, couldn't run as fast as some of the other emerging predators, and didn't have the specialized tools of the saber-toothed cats. It was a generalist in a world that was starting to favor specialists. And in that competition, generalists lose. Some researchers have suggested that Panthera gombasoagensis might have survived longer than the fossil record currently shows, persisting in isolated refugia, where conditions remained favorable. There are hints, disputed and controversial, of similar cats appearing in later deposits, though whether those are true gombasoagensis or early cave lions is still debated. The fossil record for European carnivores during this period is patchy, so it's possible we're missing parts of the story. What's clear is that this cat was a bridge species, connecting the earlier, more primitive big cats of the Pliocene with the later, more derived forms of the Pleistocene. It saw the world change, adapted as much as it could, and eventually was replaced by the next generation. In evolutionary terms, that's not failure. That's how the system works. Every species is temporary, a snapshot of one moment in a constantly shifting landscape. Panthera gombasoagensis had its moment, and then the Ice Age moved on. Crocuta spelaea, the cave hyena that wasn't a scavenger. When people think of hyenas, they think of scavengers, the cleanup crew that picks over lion kills and cackles in the night. The Ice Age cave hyena, Crocuta spelaea, wrecks that stereotype. This wasn't a timid scavenger. It was a top-tier predator, bigger and more powerful than modern spotted hyenas, capable of taking down prey on its own and dominating other carnivores at kill sites. The fossils show an animal that was doing the hunting, not just cleaning up after others. Cave hyenas lived across Europe and Asia during the Pleistocene, overlapping with Neanderthals, early modern humans, cave lions, and other major predators. Their remains are common in cave sites, which is how they got their name, but like cave lions, they didn't actually live in caves full-time. They used caves as dens, places to raise cubs and shelter during harsh weather, but most of their lives were spent outside, roaming territories and hunting across open landscapes. The bite force of a cave hyena was absurd. Modern spotted hyenas already have one of the strongest bites relative to size of any mammal, capable of crushing bones that lions and leopards leave behind. Cave hyenas were larger, with even more robust skulls and jaw muscles. Fossil bones from their den sites show extreme processing, bones cracked open for marrow, skulls crushed, and even dense limb bones reduced to fragments. They weren't leaving anything to waste. That bone-crushing ability gave them access to nutrients other predators couldn't reach. After a kill, other carnivores would eat the muscle and organs, then leave. Cave hyenas would move in and destroy the skeleton, extracting every last calorie. In lean times, that would be the difference between survival and starvation. It also meant they could scavenge more effectively than anything else, turning abandoned carcasses into meals when hunting opportunities were scarce. But the evidence shows they were active hunters too. Fossil sites contain the remains of prey animals that were clearly killed and processed by hyenas, not just scavenged. Large herbivores like horses, reindeer, and young bison showed tooth marks consistent with hyena dentition, and the bones are often found in concentrations suggesting they were brought back to den sites. That's hunting behavior, not scavenging. Modern spotted hyenas hunt cooperatively, and cave hyenas likely did the same, using pack tactics to bring down prey much larger than themselves. One of the creepiest aspects of cave hyena behavior is what's been found in their dens. Mixed in with prey bones are the remains of other carnivores, cave bear cubs, fox bones, and even the occasional scavenged remains of other hyenas. Whether they were actively hunting other predators or just opportunistically eating whatever they could kill is unclear, but it shows they weren't shy about competition. If it had meat on it, it was food. Human interactions with cave hyenas were probably tense. Both species used caves, and there are sites where human tools and hyena bones are found in the same layers, sometimes even showing evidence of conflict. Hyena-gnawed human bones and human-broken hyena bones suggest that neither side had a monopoly on violence. Cave hyenas were large, aggressive, and territorial. Early humans would have had to be cautious, armed, and organized to keep them at bay. The extinction of cave hyenas at the end of the Pleistocene is another casualty of the megafaunal collapse. As large herbivores disappeared, the prey base dried up. Spotted hyenas in Africa survived because they're incredibly adaptable, eating everything from insects to fruit to whatever they can scavenge or hunt. Cave hyenas, more specialized and reliant on large prey, couldn't make that shift. When the big animals vanished, the bone crushers followed. Ursus maritimus tyrannus, the giant polar bear, that ruled the Arctic. Modern polar bears are the largest land carnivores alive today, apex predators of the Arctic with few natural threats. But during the Ice Age, they had a bigger, meaner relative, Ursus maritimus tyrannus, sometimes called the tyrant polar bear. This subspecies or related form was significantly larger than today's polar bears, possibly reaching sizes comparable to the short-faced bear. It roamed the frozen edges of the northern ice sheets, hunting seals, fish, and anything else it could catch in one of the harshest environments on Earth. The fossil record for Ice Age polar bears is frustratingly sparse. They lived on ice and coastlines, environments where fossilization is rare. Most remains come from isolated finds in Scandinavia, northern Russia, and a few scattered sites in Alaska and Canada. What we do have shows animals larger and more robust than modern polar bears, with thicker skulls and more powerful limbs. These weren't just surviving in the Arctic, they were dominating it. Hunting strategy would have been similar to modern polar bears, ambushing seals at breathing holes, stalking across ice, and scavenging whale carcasses when available. But the larger size of Ursus maritimus tyrannus suggests it could take on bigger prey or compete more effectively with other predators. A modern polar bear avoids conflict with packs of wolves or large groups of other bears. A giant polar bear might not have had to. One interesting question is diet flexibility. Modern polar bears are highly specialized, relying almost entirely on seals for fat and protein. When ice melts and seal hunting becomes difficult, they struggle. Did the Ice Age polar bear have more options? The environment was different. More ice, more stable conditions, potentially more prey diversity along coastlines. Or maybe it was even more locked into seal hunting, using its size to outcompete others at the best hunting spots. The extinction or transition of Ursus maritimus tyrannus into modern polar bears is unclear. As the ice sheets retreated and the climate warmed, Arctic conditions shifted, coastlines changed, prey distributions altered. Larger bears might have struggled with the changing food availability, while smaller, more flexible individuals survived and passed on their genes. Over time, the giant form disappeared, leaving the slightly smaller but still massive polar bears we know today. There's also genetic evidence that polar bears interbred with brown bears during the Ice Age, especially at their southern range limits, where the two species overlapped. Those hybridization events may have introduced genes that help polar bears adapt to changing conditions, but they also may have diluted the genetic distinctiveness of the larger forms. If Ursus maritimus tyrannus was a separate lineage, those introgression events could have absorbed it back into the broader polar bear population. The story of Ice Age polar bears is really the story of the Arctic itself, a constantly shifting battleground of ice, water, and life, trying to survive in between. The bears we see today are survivors, the end result of countless generations adapting, shrinking, shifting, and enduring. The giant tyrant form is gone, but the genes, the strategies, and the sheer toughness remain, locked into one of the last truly wild predators on Earth. Dinobastus cirrus, the last saber-tooth in North America. While smilodon gets all the fame, Dinobastus cirrus was the last saber-toothed cat standing in North America, surviving right up until the end of the Ice Age. It was smaller and more lightly built than smilodon, with shorter, more curved sabers that looked like a scaled-down version of the classic design. But that lighter build might have been an advantage. In a changing world, being big and specialized is risky. Being smaller, faster, and more flexible might be the key to hanging on just a little longer. Dinobastus fossils come primarily from the southern United States and Mexico, concentrated in regions that were warmer and more vegetated than the open grasslands further north. This wasn't a tundra cat or a grassland specialist. It lived in mixed environments, forests, scrublands, river valleys, where prey was smaller and more diverse. Instead of targeting mammoths and giant bison, Dinobastus likely hunted deer, peccaries, and medium-sized herbivores. The anatomy reflects that shift. The body was more gracile, the limbs longer relative to size, and the overall build closer to a modern cougar than to Smilodon's bulky frame. The sabers were still present, still dangerous, but they weren't as extreme. Dinobastus could probably deliver a saber bite to the throat or neck of its prey, but it didn't need the same grappling strength that Smilodon used. It could rely more on speed and agility, getting in and out fast rather than wrestling prey to the ground. This flexibility might explain why Dinobastus lasted longer than most other saber-toothed cats. As the Ice Age ended and environments fragmented, specialists struggled. Smilodon, locked into hunting megafauna with a specific strategy, couldn't adapt fast enough. Dinobastus, with its lighter build and broader prey base, had more options. It could shift habitats, target different prey, and survive in changing conditions that killed off its relatives. But even that flexibility had limits. By around 10,000 years ago, Dinobastus was gone. The exact cause is debated. Climate change, habitat loss, prey decline, human competition, probably all of them working together. The southern regions where Dinobastus lived were changing fast. Forests were shifting, rainfall patterns were different, and the prey base was in flux. A predator that had survived by being adaptable finally ran out of places to adapt to. Some researchers have suggested that Dinobastus might represent a transitional form, a saber-tooth in the process of losing its sabers and shifting toward a more generalized cat body plan. The shorter, less extreme sabers hint at that possibility. If the lineage had survived another few 100,000 years, maybe it would have evolved into something more like a cougar or jaguar, with the sabers reduced to normal canines. But evolution doesn't care about potential. It only cares about survival in the present moment. And in that moment, Dinobastus couldn't make it work. The extinction of Dinobastus marks the end of the saber-toothed cat story in North America. For millions of years, cats with elongated canines had been a dominant feature of the continent's predator guilds. They'd evolved multiple times in multiple lineages, converging on the same basic design because it worked. But at the end of the Ice Age, that design stopped working. The world changed, and the sabers couldn't keep up. Dinobastus was the last one to realize it. Megastotherium osteothlastes, the hyena predator built like a tank. Technically, Megastotherium lived before the classic Ice Age, dying out in the early Miocene around 20 million years ago. But it deserves mention because it shows what predatory mammals are capable of when pushed to extremes. Megastotherium was a member of the Hyenodon family, not related to modern hyenas, but filling a similar ecological role. It was one of the largest mammalian carnivores ever, possibly exceeding 1,500 pounds, with a skull nearly 2 feet long and jaws that could crush bone with ridiculous force. The fossils come from Africa and parts of the Middle East, regions that were much lusher and more forested during the Miocene than they are today. Megastotherium lived alongside early elephants, massive pigs, and primitive ungulates, all of which were on its menu. The teeth were built for two things: slicing meat and crushing bone. The carnassials were huge, and the premolars were thick and conical, designed to crack through bone the way modern hyenas do, but scaled up to handle much larger prey. Imagine a predator the size of a grizzly bear, with the bite force of a hyena and the hunting style of a solitary ambush killer. That's Megastotherium. It wasn't chasing prey across open ground. It was hiding, waiting, and then exploding forward in a short, brutal attack. One bite to a limb or spine and the prey was crippled. Then it was just a matter of time, waiting for blood loss and shock to finish the job. The extinction of hyenodonts like Megastotherium coincides with the rise of modern carnivoran families, true hyenas, big cats, and canids. These new predators were faster, more efficient, and better at adapting to changing conditions. Hyenodonts, for all their power, couldn't compete. They were evolutionary dead ends, experiments that worked for millions of years and then got replaced by something better. But for a brief window, Megastotherium was the most terrifying land predator on the planet, and nothing else came close. Pachycrocuta brevirostris, the giant hyena that hunted cave bears. While cave hyenas were tearing through Ice Age Europe, an even larger species was dominating parts of Asia. Pachycrocuta brevirostris, the giant short-faced hyena. This animal was bigger than any hyena alive today, possibly reaching 400 pounds, with a massive skull and bone-crushing jaws that made cave hyenas look delicate. It lived across Asia, from China to Europe, and its fossil record suggests it was one of the most successful predators of the early Ice Age. The skull of Pachycrocuta is absurdly robust. The sagittal crest, the ridge along the top of the skull where jaw muscles attach, is huge, indicating incredible bite force. The teeth are thick, conical, and worn down from constant use, cracking through bones. Fossil dendrites associated with Pachycrocuta show bone accumulations that are completely processed. Long bones smashed open, skulls crushed, every scrap of marrow extracted. This wasn't scavenging. This was systematic exploitation of every part of a carcass. One of the most famous Pachycrocutae sites is in China, where researchers found a cave packed with bones of prey animals, including juvenile cave bears. The presence of bear remains suggests that Pachycrocuta was actively hunting or scavenging one of the most dangerous herbivores of the Ice Age. Cave bears were massive, heavily built, and capable of defending themselves. The fact that Pachycrocuta was dragging them back to den sites shows just how powerful and fearless this hyena was. Pachycrocuta also overlapped with early humans and hominins. Fossil sites show evidence of conflict, with hyena-gnawed human bones and human-modified hyena bones. Whether these encounters were violent confrontations or just opportunistic scavenging of each other's kills is unclear, but it adds another layer to the story. Early humans in Asia weren't just dealing with big cats and bears. They were competing with hyenas that could crush bones with their jaws and weren't intimidated by tool-using primates. The extinction of Pachycrocuta happened around 500,000 years ago, earlier than most Ice Age predators. The reasons are debated. Climate change is the usual suspect, but there's also evidence that competition with expanding populations of other carnivores, including humans, played a role. As environments fragmented and prey distributions shifted, the giant hyena's niche contracted. It couldn't adapt fast enough, and by the middle Pleistocene it was gone, replaced by smaller, more flexible hyena species. Machairodus, the original saber-tooth. Destonothene. Before smilodon, before homotherium, before any of the famous Ice Age saber-tooths, there was Machairodus, the original model that set the template. This genus appeared in the Miocene over 10 million years ago and spread across Africa, Eurasia, and eventually into North America. Different species varied in size and build, but all of them shared the same basic design: elongated upper canines, powerful bodies, and a hunting strategy built around deep, slashing bites. Machairodus was one of the first large predators to fully commit to the saber-tooth design. Earlier forms had slightly enlarged canines, but Machairodus pushed it to the next level, with sabers that could reach several inches in length. The skull was adapted to handle the stress of using those teeth, with reinforced attachment points for jaw and neck muscles, and a gape that could open wide enough to clear the sabers during a bite. The success of Machairodus set off an evolutionary arms race. Prey animals responded by developing thicker hides, more robust skulls, and defensive behaviours. Predators responded by getting bigger, stronger, and more specialised. Over millions of years, this feedback loop produced the incredible diversity of saber-toothed cats we see in the fossil record. Every lineage was experimenting with the same basic tool, tweaking it, refining it, pushing it in different directions. But Machairodus itself didn't make it to the Ice Age. The genus went extinct in the Pleistocene around 2 million years ago, replaced by newer, more derived saber-tooths like homotherium and smilodon. It was outcompeted, outspecialized, or just unlucky as environments changed and new predators moved in. But its legacy lived on in the descendants that inherited its design, carried it forward, and made it famous. Every famous saber-tooth from the Ice Age owes something to Machairodus, the cat that proved the design worked in the first place. Epicyon haydeni, the bone-crushing dog that ate like a hyena. Epicyon haydeni was a dog technically, but it hunted and fed like a hyena. It lived in North America during the late Miocene, around 5 to 10 million years ago, and it was one of the largest canids ever, weighing up to 370 pounds. The skull was massive, the jaws incredibly powerful, and the teeth were built for crushing bone. This wasn't a pursuit predator like a modern wolf. It was an ambush killer and scavenger, filling a niche that hyenas would later dominate. The teeth are the giveaway. Epicyon had enlarged premolars, thick and conical, designed to crack through bone. The carnassials were robust, built for slicing meat, but also strong enough to handle tough material. Fossil evidence shows heavy tooth wear, suggesting a diet that included a lot of bone processing. This dog was eating entire carcasses, not just the muscle and organs. It was extracting marrow, crushing skulls, and leaving nothing to waste. Epicyon's body was heavily built, with short, powerful limbs and a stocky frame. It wasn't built for long-distance running or high-speed chases. It was built for strength, for grappling, and for dominating carcasses in competition with other scavengers and predators. In the ecosystems where it lived, that strategy worked. Prey was abundant, and an animal that could maximize calorie extraction from every kill had an advantage. But Epicyon went extinct as climates changed and ecosystems shifted. The late Miocene and early Pliocene saw major changes in North American environments, with forests giving way to grasslands and prey distributions changing. The niche that Epicyon had carved out, bone-crushing scavenger/predator, was still viable, but new competitors were moving in. Smaller, more flexible canids were adapting better to the changing world, and Epicyon couldn't keep up. The extinction of Epicyon marks the end of the bone-crushing dog experiment in North America. Later canids like dire wolves would have powerful jaws, but they never reached the same level of specialization. Hyenas, which evolved in the Old World, would eventually perfect the bone-crushing niche. But by then, Epicyon was long gone. It was a dead-end branch, an evolutionary experiment that worked for a while and then got replaced. Borophagus, the small bone crusher that outlasted giants. If Epicyon was the giant bone-crushing dog, Borophagus was the smaller, scrappier version that survived longer by being more adaptable. Borophagus diversus and related species lived across North America from the late Miocene into the Pliocene, overlapping with Epicyon, but outlasting it by millions of years. These dogs were coyote-sized, heavily built, and equipped with the same bone-crushing teeth as their larger relatives. But their smaller size gave them flexibility. The skull of Borophagus shows the same adaptations as Epicyon, powerful jaws, enlarged premolars, heavy tooth wear, but in a more compact package. A smaller predator needs less food, can survive in more marginal habitats, and can exploit smaller prey and carcasses that bigger predators ignore. That's a survival advantage when environments are unstable and resources are patchy. Borophagus likely hunted small to medium-sized prey on its own or in pairs, and scavenged larger carcasses when opportunities arose. The bone-crushing teeth meant it could outlast other scavengers at a kill site, processing bones that others left behind. In lean times, that ability to extract every calorie from a carcass would be the difference between survival and starvation. The extinction of Borophagus happened around 2 million years ago, at the end of the Pliocene. The reasons are similar to Epicyon: changing climates, shifting ecosystems, and new competitors. By this point, modern canid lineages, wolves, coyotes, foxes, were becoming dominant, and they were faster, more flexible, and better suited to the new environments. The bone-crushing dogs, for all their power, couldn't compete. They'd had a good run, millions of years dominating scavenging niches across North America. But in the end, evolution moved on. Homo sapiens, the predator that killed with ideas. You can't talk about Ice Age predators without including us. Humans weren't the biggest, fastest, or strongest predators of the Pleistocene, but we were the most dangerous. We didn't have claws, fangs, or armour. We had brains, tools, and cooperation. And that combination turned a relatively weak primate into the apex predator of the entire planet, capable of hunting and killing animals that no other predator could touch. Modern humans, Homo sapiens, appear in the fossil record around 300,000 years ago in Africa. But the real predatory revolution happens later, during the Ice Age, as we spread across the globe. By 50,000 years ago, humans had colonized Australia. By 15,000 years ago, we were in the Americas. Everywhere we went, megafauna started disappearing. Mammoths, giant sloths, marsupial lions, moas, species that had survived for millions of years, vanished within centuries or millennia of human arrival. The tools are what made the difference. A sharpened stick is a spear, a sharpened rock is a knife. Put them together and you can wound animals from a distance, bleeding them out without ever getting close enough to be in danger. Add fire and you can drive prey into ambushes or over cliffs. Add cooperation and a group of humans can take down a mammoth, an animal that weighs 10,000 pounds and could kill any single person with one step. But the real weapon was strategy. Humans could plan hunts days in advance, track prey over long distances, predict animal behaviour, and adapt tactics on the fly. We could learn from mistakes, teach our children, and accumulate knowledge across generations. A saber-toothed cat was born knowing how to hunt. A human had to learn, but once learned, that knowledge could be passed down and improved. Every generation got better, smarter, more efficient. The Ice Age was the testing ground. Humans learned to survive in environments that should have killed us: frozen tundra, deserts, high mountains, dense jungles. We developed clothing, shelter, and sophisticated tools. We domesticated fire and used it as a weapon, a source of warmth and a way to process food. We formed social groups that could tackle problems no individual could solve. And in the process, we became the most dangerous predator the world had ever seen. The megafaunal extinctions at the end of the Pleistocene coincide too closely with human expansion to be a coincidence. Climate change played a role, sure, but humans were the tipping point. We didn't just hunt these animals. We outcompeted them, altered their habitats, and disrupted ecosystems in ways that made survival impossible. By the time the ice melted and the world warmed up, most of the giant prey animals were gone, and so were the predators that depended on them. The difference is, we survived. Every other apex predator of the Ice Age, the saber-tooths, the giant bears, the dire wolves, went extinct, or barely held on. Humans not only survived, we thrived. We spread to every continent, adapted to every environment, and eventually built civilizations. The Ice Age predators were built for one world. We learned to survive in any world. And in the end, that made us the deadliest predators of them all. If these Ice Age killing machines taught us anything, it's that evolution doesn't care how big you are, how sharp your teeth are, or how perfectly adapted you are to your environment. When the world changes, the specialists die and the adaptable survive. The mammoths are gone, the saber-tooths are gone, the dire wolves, the short-faced bears, the giant lions, all gone. But we're still here, and that's the most terrifying part of the whole story. Amphictyonidae, the bear dogs that hunted in packs. Take a bear. Now cross it with a wolf. Give it the bone-crushing jaws of a hyena and the intelligence to hunt in coordinated groups. That's an amphictynid, or bear dog, a family of predators that dominated North America and Eurasia for over 30 million years, before going extinct just as the Ice Age was ramping up. These weren't transitional forms between bears and dogs. They were their own distinct lineage, one that evolved a body plan so successful it spread across 2 continents and produced dozens of species ranging from fox-sized to bear-sized killers. Amphictyonids first appear in the fossil record around 40 million years ago, in the Eocene, and they hit their peak during the Miocene, roughly 20 to 5 million years ago. The fossils show incredible diversity. Some species were small and weasel-like, probably hunting rodents and small prey. Others were massive, weighing over 600 pounds, with skulls the size of grizzly bears and teeth that could crack bones. The largest forms, like Amphicyon ingens, were apex predators, sitting at the top of food chains and answering to nothing. The anatomy is what makes them so weird. The skull looks dog-like, with a long snout and forward-facing eyes for depth perception. But the body is bear-like, with heavy limbs, plantigrade feet, walking on the whole foot like a bear rather than the toes like a dog, and a robust muscular build. The teeth are a mix, sharp carnassials for slicing meat, but also thick premolars for crushing. They could process a carcass completely, eating meat, cracking bones, and leaving nothing behind. That versatility was probably their secret. In the ever-changing environments of the Miocene, prey types and availability shifted constantly. A predator that could hunt a wide range of animals, from small mammals to large ungulates, and that could scavenge efficiently when hunting failed, would have a huge survival advantage. Amphictyonids weren't locked into one strategy or one prey type. They could adjust, adapt, and exploit whatever food source was available. Some fossil evidence suggests pack behavior. Multiple individuals of the same species have been found in close proximity at kill sites, and the social structure of their environments, open woodlands and grasslands, would favour group hunting. A pack of bear dogs working together could bring down prey far larger than any single individual could handle. The same way modern wolves hunt elk or bison. The combination of size, power, and coordination would make them terrifying to encounter. But they also faced intense competition. During the Miocene, North America was packed with predators. Bone-crushing dogs like Epicyon, early big cats, saber-tooths, and later true bears were all competing for the same resources. Amphictyonids held their own for millions of years, but as the climate continued to shift and new predator lineages evolved, their niche got squeezed. They were good at everything, but not the best at anything. And in evolution, that's a dangerous place to be. The last amphictyonids went extinct around 2.5 million years ago, right as the Pleistocene was beginning. Climate change is the obvious culprit. The transition from Pliocene to Pleistocene brought major environmental shifts, with grasslands expanding, forests fragmenting, and prey distributions changing. New predators like wolves and hyenas were moving into North America and Eurasia, bringing refined hunting strategies and social structures that amphictyonids couldn't match. The bear dogs, for all their adaptability, ran out of options. What's frustrating is that we'll never see how they really behaved. Bones tell you structure but not personality. Did they hunt at dawn or dusk? Did they vocalize like wolves or stay silent like cats? Did mothers train their young in complex hunting techniques, passing down knowledge across generations? All of that is lost. The bear dogs are ghosts now, echoes in the fossil record of a predator family that once ruled and then vanished, replaced by the ancestors of the animals we know today. Barbarophiles, the false saber-tooth that perfected the design. Not every saber-toothed predator was a cat. Barbarophiles looked like a saber-toothed cat, hunted like a saber-toothed cat, and had the classic long canines that define the group. But it wasn't a cat at all. It was a nimravid, a member of an older, more primitive family that evolved saber teeth completely independently. This is convergent evolution at its most extreme. Two separate lineages, separated by millions of years, arriving at the exact same solution to the problem of killing large prey. Barbarophiles lived in North America during the late Miocene, around 10 to 7 million years ago. It was one of the last nimravids, a family that had been experimenting with saber teeth long before true cats even appeared. The fossils show an animal about the size of a modern lion, heavily muscled, with sabers that extended well past the lower jaw. But here's the twist. Barbarophiles had flanges on the lower jaw, bony sheaths that protected the sabers when the mouth was closed. True saber-toothed cats never evolved that feature. Those jaw flanges suggest Barbarophiles was using its sabers differently than later cats like Smilodon. The sheaths would protect the teeth from breaking during struggles with prey, allowing the predator to bite and hold without risking damage. That opens up new hunting strategies. Instead of the careful, precision throat bite that Smilodon used, Barbarophiles might have been able to grab prey by the neck or shoulder, hold on, and use its body weight to drag the animal down while the sabers did internal damage. The limb structure supports this. Barbarophiles was built like a tank, with short, incredibly powerful legs and a heavy, muscular body. It wasn't chasing prey across open ground. It was ambushing from cover, launching short bursts of explosive power, and then using sheer strength to wrestle prey into submission. The sabers weren't just weapons, they were tools, used in combination with grappling, weight, and leverage to bring down animals that might outweigh the predator by hundreds of pounds. The prey base in late Miocene North America was perfect for this strategy. Large, slow-moving herbivores like early horses, camels, and rhinos were abundant. These animals weren't particularly fast or agile, but they were big and tough, with thick hides and heavy builds. A predator that could get close, grab on, and hold on had the advantage. Speed didn't matter. Endurance didn't matter. Only power and the ability to deliver a killing bite while under stress. Barbarophiles went extinct around 7 million years ago, long before the Ice Age. The reasons are debated, but the timing coincides with major environmental changes. Grasslands were expanding, forests were fragmenting, and new predator types were evolving. True cats, more agile, more adaptable, were moving into Barbarophiles' niche. The nimravids had pioneered the saber-tooth design, but the true cats perfected it, and in that competition, the older lineage lost. What's haunting about Barbarophiles is that it represents a road not taken. If nimravids had survived into the Pleistocene instead of true cats, the Ice Age might have looked completely different. Maybe the flanged jaw design would have become standard. Maybe saber-toothed predators would have evolved even more extreme weaponry. But evolution doesn't do what-ifs. Barbarophiles had its moment, proved the saber-tooth concept worked, and then stepped aside. The true cats took over, refined the design, and made it famous. But the nimravids did it first. Zenosmilus lycaonoides. the hypercarnivore wolf that conquered Eurasia. Most wolves are opportunistic, eating whatever they can catch or scavenge, mixing in plant matter, insects and carrion when meat is scarce. Xenochaon lycaonoids were not most wolves. This animal was a hypercarnivore, a specialist that ate almost nothing but meat, and it evolved into one of the most efficient pack hunters the Pleistocene ever produced. It ranged across Europe, Asia and Africa during the Ice Age, working in groups to bring down prey far larger than itself, and leaving almost no ecological niche unexploited. Zenosmilus looked superficially like a modern African wild dog or a grey wolf, but the skull and teeth reveal the difference. The carnassials, the slicing teeth, were enormous, sharp, and specialised for cutting meat with maximum efficiency. The premolars were reduced, showing less emphasis on crushing bone compared to dire wolves or hyenas. This was a precision instrument, a predator designed to slice through muscle and organs quickly, efficiently, and without wasting energy on parts of the carcass it couldn't digest. The limbs were long and built for endurance. Zenosmilus wasn't an ambush predator. It ran prey down over long distances, the way African wild dogs do today. Pack members would take turns pressing the attack, exhausting the prey until it couldn't run anymore. Once the animal collapsed, the pack would move in and start feeding, often while the prey was still alive. It's brutal, efficient, and incredibly effective. No single wolf could do it, but a coordinated pack becomes an unstoppable force. Fossil evidence shows Zenosmilus lived and hunted in groups. Multiple individuals are found at den sites, and the age distribution, juveniles, subadults, and adults, suggests stable, long-term packs. That level of social complexity requires communication, cooperation, and probably a hierarchy. Pack members would need to coordinate during hunts, share food, care for young, and defend territory against rival packs. This isn't just instinct. This is intelligence, social learning, and culture. The prey that Zenosmilus targeted was dangerous. In Eurasia, they were hunting horses, reindeer, saiga antelope, and possibly young mammoths or rhinos. These animals were fast, alert, and lived in herds, which meant hunting them required strategy. A lone wolf would be spotted and avoided. A pack could split up, drive prey toward ambush points, cut off escape routes, and overwhelm defences through sheer numbers and persistence. The hypercarnivorous teeth meant they could process kills quickly, eating fast and moving on before competitors arrived. Zenosmilus' geographic range is staggering. Fossils turn up from Spain to China and south into Africa. That's one of the widest ranges of any Pleistocene carnivore, rivaling humans in its ability to adapt to different environments. Whether it was frozen tundra, temperate forests, or arid grasslands, Zenosmilus found a way to survive. That adaptability suggests behavioural flexibility. Different populations probably hunted different prey and used different strategies depending on local conditions. The relationship between Zenosmilus and early humans is murky but fascinating. They overlapped in time and space, competed for the same prey, and probably encountered each other regularly. Some researchers think humans might have learned pack hunting strategies from observing wolves like Zenosmilus. Others suggest the wolves scavenged from human kills, forming the early relationships that would eventually lead to domestication. There's no direct evidence either way, but the coincidence is hard to ignore. Zenosmilus went extinct around 500,000 years ago in most of its range, though some populations may have persisted longer in isolated areas. The extinction coincides with the rise and spread of grey wolves, Canis lupus, a more generalised species that could eat a wider variety of foods and adapt to more conditions. Zenosmilus, for all its hunting prowess, was locked into the hypercarnivore niche. When prey populations shifted or environments changed, it couldn't pivot. Grey wolves could, and in that competition, the specialists lost to the generalists once again. Agriotherium africanum, the giant omnivore bear that ate everything. Most Ice Age predators were specialists: saber-tooth for big game, wolves for pack hunting, hyenas for bone crushing. Agriotherium africanum broke that pattern completely. This bear was huge, omnivorous, and willing to eat literally anything it could catch, dig up, or scavenge. It lived across Africa, Europe, and Asia during the Pliocene and early Pleistocene, reaching sizes comparable to modern polar bears, and occupying a niche that no other predator could touch, the ultimate generalist. Agriotherium wasn't a true bear in the modern sense. It belonged to a more primitive lineage that split off before modern bears evolved. But the body plan was similar: massive, heavily built, with powerful limbs, plantigrade feet, and a large skull. The teeth, though, tell the real story. Unlike modern grizzlies or black bears, Agriotherium had more developed carnassials, suggesting it ate more meat than its modern relatives. But it also had broad molars for grinding plant matter. This bear could kill and eat prey, but it could also survive on roots, berries, and scavenged carcasses when meat was scarce. That flexibility made Agriotherium incredibly dangerous. A specialized predator has weaknesses. It needs specific prey, specific habitats, specific conditions. A generalist doesn't. Agriotherium could hunt when hunting was good, scavenge when opportunities arose, and switch to plant-based foods when meat wasn't available. It could live in forests, grasslands, river valleys, and mountainous regions, exploiting whatever resources each environment offered. That's not just survival, that's dominance. The size was a weapon in itself. A full-grown Agriotherium could weigh over 900 pounds, larger than most of the predators it competed with. That size meant it could dominate kill sites, chasing off lions, hyenas, and even saber-toothed cats when it wanted access to a carcass. It could also hunt prey that other predators avoided, large dangerous animals like juvenile elephants, rhinos, or hippos. The combination of power, size, and willingness to eat anything made it one of the most successful large carnivores of its time. Fossil sites show Agriotherium with a wide range of prey and food sources. Tooth wear indicates it was crunching bones, eating tough plant material, and processing everything in between. Isotope studies of the bones show a diet that varied wildly, sometimes heavy on meat, sometimes leaning toward plants, suggesting seasonal shifts or opportunistic feeding, depending on what was available. This wasn't a picky eater. This was an eating machine that would consume whatever provided the most calories. One of the strangest aspects of Agriotherium is its geographic spread. It's found in Africa during a time when most large bear species were restricted to Eurasia or North America. How it got there and how it survived in competition with Africa's dense predator guilds is still debated. Some researchers think it migrated during periods when climate allowed movement between continents. Others suggest it evolved in Africa independently and spread northward. Either way, its presence shows that even in ecosystems packed with lions, hyenas, and saber-tooths, a big omnivorous bear could find a place. Agriotherium went extinct around 1.5 million years ago, vanishing as the Pleistocene progressed. The exact cause is unclear. True bears, ancestors of modern brown bears and black bears, were evolving and spreading, bringing more refined adaptations and possibly outcompeting the older lineage. Climate change was fragmenting habitats, and human ancestors were spreading, adding new competition for resources. Agriotherium, for all its flexibility, couldn't hold on. The world moved on, and the giant omnivore bear became another fossil, another extinct experiment in how to survive. Thylacoleo carnifex, the marsupial lion, with bolt cutters for teeth. Australia during the Ice Age was its own nightmare zone, and Thylacoleo carnifex was the apex predator that ruled it. This wasn't a placental mammal like the lions, bears and saber-tooths dominating other continents. It was a marsupial, more closely related to kangaroos and wombats than to any true carnivore. But evolution doesn't care about ancestry. It cares about what works. And what Thylacoleo evolved was one of the most bizarre and effective killing adaptations in the history of predators. Teeth that worked like bolt cutters, capable of shearing through bone with the highest bite force relative to size of any known mammal. Thylacoleo lived in Australia from the late Pliocene through the Pleistocene, surviving until around 30,000 years ago, right around the time humans arrived on the continent. The fossil record shows an animal about the size of a modern leopard or jaguar, heavily built, with a short face, incredibly powerful jaws, and a body plan that doesn't quite match any living predator. The front limbs were massively muscled, ending in huge retractable claws that were almost certainly used for climbing and grappling prey. The teeth are what make Thylacoleo truly alien. Instead of long canines like cats or bone-crushing molars like hyenas, it had enormously enlarged premolars that acted like shearing blades. These teeth were self-sharpening, continually scraping against each other to maintain a razor edge. When Thylacoleo bit down, those premolars would slice through hide, muscle and bone like industrial scissors cutting through sheet metal. The bite force calculations are absurd. Thylacoleo could deliver more force per kilogram of body mass than any big cat, bear or other carnivore measured. So how did it hunt? The claws suggest climbing ability, which is bizarre for an ambush predator of that size. Some researchers think Thylacoleo hunted from trees, dropping onto prey from above and using those massive claws to grab and hold while delivering a shearing bite to the spine or skull. Others suggest it was more terrestrial, using the claws for grappling and controlling prey during ground-based attacks. The truth might be somewhere in between, a flexible hunter that could climb when advantageous and hunt on the ground when necessary. The prey base in Ice Age Australia was full of strange, massive animals, giant kangaroos, enormous wombats called diprotodons, and huge, flightless birds. Many of these animals were larger than Thylacoleo, heavily built and capable of defending themselves. A direct attack would be suicide, but an ambush from above or a precision strike targeting the spine or skull could cripple even a massive animal before it could fight back. The shearing teeth meant Thylacoleo didn't need to wrestle and suffocate its prey like a lion. One deep bite, severing the spinal cord or major blood vessels, and the job was done. Fossil evidence shows Thylacoleo using caves as dens, and some of these caves have preserved not just bones, but also scratch marks on the walls, showing where the claws dug in as the animals climbed. The marks are high up, meters off the ground, proving that these predators were comfortable in vertical spaces that modern big cats would never attempt. That vertical mobility would give Thylacoleo access to prey and hunting opportunities that ground-bound predators couldn't reach. The extinction of Thylacoleo coincides with human arrival in Australia. Archaeological evidence shows humans hunting and butchering megafauna, using fire to alter landscapes and competing for resources. Whether humans directly hunted Thylacoleo or just removed the prey base it depended on is debated, but the timing is hard to ignore. Within a few thousand years of human arrival, most of Australia's large predators and herbivores were gone. Thylacoleo, the marsupial lion with the most powerful bite on the continent, couldn't adapt fast enough to survive the newcomers. What makes Thylacoleo's story even more tragic is what it represents. This was convergent evolution at its finest, a marsupial that independently evolved predatory adaptations that rivaled anything the placental mammals produced. It proved that the carnivore body plan wasn't limited to one evolutionary lineage, But that success didn't matter when the world changed. Thylacoleo had ruled Australia for hundreds of thousands of years, outlasting climate swings, volcanic eruptions, and massive environmental shifts. But it couldn't outlast humans. None of them could. And that's how the Ice Age ended. Not with ice, not with climate, but with a new kind of predator that didn't need size, speed, or teeth. All we needed was our brains, and that was enough to kill everything else.